Okay, so here we are with the last section of the chapter 12 notes. Now, in the last part, we looked at what these revolutions look like when you have a right triangle or a rectangle that's on the axis, on the line that you're revolving around, right? And if you recall, the right triangle makes a cone and the rectangle makes a cylinder. Because if you're on the axis, that's a height, and if you're perpendicular to the axis, that is going to make a circle. That segment is perpendicular to the axis, that's a radius of a circle. So what happens if we don't have a rectangle or a right triangle? So look at example 1 for today. This is a triangle, but it's not a right triangle. So if I want to revolve around the x-axis, what would that look like? So what you want to do is, just like we did last time, okay? You're going to trace the x-axis, which is right here. That's the line that we're revolving around. And then I want you to flip it down. I want you to reflect down. So you're going to trace this in. Okay? Now, what is that going to look like? Where are we going to draw on the circles? Because when you revolve 360, there's going to be a circle somewhere, right? So what you want to do, since we want right triangles and rectangles, what you can think about it as is like, where could I draw in a line segment that would turn this into just rectangles and right triangles? So I want you to look right here. If I were to go to this vertex, 3, 5, sorry about that, and just go straight down here, drawing this segment. Do you see how I'm turning this big triangle into 2 little right triangles? Okay? So think about it like this, here. If I draw in that line right there, yeah, that's the right triangle. So if I flip that triangle down over the x-axis and revolve that, what's it going to make? It's going to be a cone. Well, what about the other side of the triangle? If I draw in the line right there, that's a right triangle also that's going to flip down over the x-axis and make a cone, right? So what it looks like then, so I literally want you to draw this in, and then treat them as, okay, that right triangle is going to make a cone, that's going to make a cone. So in the middle here is where the circle is. And it ends up looking like this, like 2 cones stuck together at their circle. So here it is. If I were going to draw this, I would trace this line on the x-axis because that's where we're revolving over. Okay? Then I would flip it down, and I want you to say, okay, right here, you're going to draw in this. And that will allow you to see, oh, that's where the circle is. This line that I'm drawing in is going to be perpendicular to the axis, so that's where the circle is going to be. The circle is going to be in the middle here, and it's going to have 2 cones going left and right. So let's see what that would look like. See? Circle's in the middle. There's the 2 cones. Now, I don't want to get too much into this right here because this is kind of, there's space here. Look what it says if I rotate around the y-axis. I'll show you what it looks like, but we're not going to delve too much into that. So let's reflect. Now, this is going to revolve all the way around this line here to this gray spot. So if you see this triangle here, that's just air, but it's in the shape of a cone. So you're going to have something that looks like this. See how it's like a cone that got the top part of it cut off? See, and there's like also a kind of gap that's cone shaped in there. We're not going to be dealing too much with that, but it's interesting to consider, to think about what these shapes are going to look like. Okay? Let's keep going. In this case, we have a trapezoid, and we want to revolve around the x-axis, right? So I'm going to trace in this line here, the x-axis. I'm going to flip down and draw this in like this. And you can do that. And it looks like home plate of a baseball field. Okay? But again, this right here, this side of the trapezoid, That's perpendicular to the axis. So that's going to be a circle right there. But what I want to do is I want my shape to look like nothing but rectangles and right triangles. So I'm also going to go here and go straight down to the axis. So basically what you're looking for these is look at all of the vertices on your shape, your original shape. See how this vertex is already on the axis? Ignore it. See how this vertex right here is already on the axis? Ignore it. See how this vertex already has a perpendicular to the axis drawn? You can ignore that. So there's one vertex left. It's right here. It's not on the axis you're revolving around, and it doesn't already have a perpendicular line drawn in, so you're going to draw it in. So you go right here, you're going to go straight down to the axis, boom. Now you turned it into a rectangle and a right triangle. So this is going to be a circle here as well. And then you can continue it all the way down here, and I'll show you what that would look like. So here we go. Here's our trapezoid. If I were doing this, I would trace the x-axis first. So we're going to trace the x-axis. That's in the purple here. Then you're going to flip down. Just a reflection over the x-axis. You can see, like I said, it looks like a home plate. This is already perpendicular. This is on the axis, this is on the axis. So this is the only vertex that's not on the axis or already perpendicular to it. That's the one you're going to draw in. So you would draw, if I were drawing this on a sheet of paper, I would draw this line straight down here. And that's a circle. So that's a circle, and this is a circle. So you have two circles. So it's going to look like a circus tent that got knocked over on its side. And here you can see. See it? Circus tent, they got knocked over on its side. So what that is it's a cylinder with a cone stuck on the side of it. Like this. Okay? So at any point on these, you can go ahead and try them on your own and then check with mine and see how it works out. But I'll show you. So this one, we started off with this triangle. We're going over the x-axis. So the original triangle has three vertices. It has this one here on the axis. It has this one here on the axis. Remember, we're facing over the x-axis. This one right here, 0, 4, that vertex is not already on the axis, and it doesn't have a perpendicular drawn. So I'm going to draw straight down, and that's where it's going. And there's only one, so you have cone. Now, this cone, this cone on the left, this cone on the right has a head of five. And then they're both sharing this circle as the base. So the radius, if the whole circle diameter is 8, the radius is right here. 1, 2, 3, 4. So that's basically two cones that have the same size that are stuck to each other, like this. Okay? So what's the volume? Well, the volume of one cone is 1/3 times pi times r squared times h. So in this case, since both cones have the same radius and the same height, I just did the volume formula once and get this answer, 80 pi over 3. Then I multiplied it by 2 because there's two cones that have the same size. That's what I did. Okay? This one is another example of the circus tent. Okay, you started off here. You're going to draw straight down here where I drew that purple line. Because this is on the axis, it's kind of hard to see. This is on the axis, this is on the axis, this is on the axis, this one is not. Draw it straight down. What you want to be is either on the axis or perpendicular to it already. This one is not. Draw it down. Clarify what it said. And it's going to look like cylinder cone, just like the last one. So what I do, I think it makes it easier, is I write out cylinder cone and I separate them. Here's the volume for cylinder, pi r squared h. Here's the volume formula for cone, 1/3 pi r squared h. And then just make sure when you're substituting the numbers in, you are doing the numbers that correspond to the object you're doing. So the cylinder, the circles are the same on the cylinder and the cone. So the radius is 6 for both. But the height of the cone is from this purple to the tip here. 1, 2, 3 is the height. The height of the cylinder is from this circle to this circle, and that's 8. So I do pi times r squared times h, that's 288 pi. For the cone, I do 1/3 times pi times radius squared times the height of the cone, which is 3. So it's 288 pi and 36 pi. Add those up, I get 324 pi. There you go. It's easier to see. It's right here. They wanted me to round, so I did. Number 3 is similar to number 1, except it's kind of vertical facing. Looks like a top. So remember, x equals -4. How do I draw in that axis? If you can't remember if it's vertical or horizontal, pick 2 points that have an x value of -4. So go -4, 1, -4, 5. Plot those points on. I want to flip the side. And I'm going to look at this vertex shows this one 36 is not. Is it already perpendicular to the axis? No. So I have to draw in a perpendicular line. I need to draw straight here. That's the radius. That's where the circle is. So if I draw it, see it going above the circle. Now, those are 2 different sized cones. So they're going to have 2 different heights here. They have the same radius. They have the same circle, right? But the one that stretches up is shorter than the one that stretches down. The one that stretches up is 5 height. The one that stretches down, 10 height. So I have 2 cones, and I'm going to calculate the volume for both of them. This is what I get here. This is what I get here. And I'm going to add them up to get this total volume. If you want to see any help on how to type those into the calculator, see the earlier videos in this chapter where I kind of demonstrated how to do that on the calculator. Now this last one here is a trapezoid, but it is not, it doesn't start off with any perpendiculars. Here we go. It looks like this. So you got to say, look, these 2 vertices are already on the axis because I'm revolving around the y-axis. So trace this here. So look at the other 2 vertices. They are not already on the axis. And they're not perpendicular. So you're going to draw on a line right here, that horizontal line. You're going to draw on a line right here. Sorry. That's where your 2 circles are going to be. So you're going to have a cylinder in the middle, and you're going to have a cone on top and a cone on bottom. And it's going to look like that. Now, if I want the exact volume of that, I have to get the volume of the top cone, the volume of the bottom cone, and the volume of the cylinder. So you can see what I do. I section it off, top cone, bottom cone, cylinder. I write out the formula, 1/3 pi r squared h, 1/3 pi r squared h, and pi r squared h. The radius is the same, it's 8 for all of them because the cylinder, the top and bottom of the cylinder, that circle, that's the base for the top cone and the base for the bottom cone, and we know in a cylinder the 2 circles are congruent. So the radius is all the same. The height of the top cone is 4, it's from here to here. The height of the bottom cone is a little bit shorter, it's 3 from here to here. And the height of the cylinder is just the distance between where we drew in those 2 lines, here to here. So you can just count here up is 10. I calculate, and then I add all of those up to get the total volume. So keep in mind that a right triangle sitting on the axis of revolution is going to make a cone, and a rectangle sitting on the axis of revolution is going to make a cylinder. And that's what we worked on in the previous section. And what we're doing here is saying, okay, if I have a shape and I want to revolve, any of the vertices that are not already on the axis or that don't already have a perpendicular drawn to the axis, we will draw in that perpendicular. And that will allow us to chop our picture, our original shape, into nothing but rectangles and right triangles, which will then allow us to make a solid made out of cylinders and cones. You're done with chapter 12. Study hard, work on your homework. Good luck.